Okay, one of the ways that you determine what's called the cell potential of a voltaic cell is that you use what's called the standard reduction potential. So remember that chart that I showed you way back a few pages ago that shows the different cell potentials right here, okay? So again, remember that these are always, and whether it's, and they're not going to give you this table anymore on the AP test. They're just going to give you the ones you need in the problem. Okay, remember that, even the new format without all these, they are always written as reductions. Okay, but like in a redox reaction, we know that here the zinc was being oxidized and the copper 2+ was being reduced. So how do you account for that? How do they come up with this 1.10 volts? Okay, the way that you do this is you take, in order to figure out the cell potential, so you want the potential of the whole cell, you take the potential at the cathode, which is the reduction process, and you subtract the potential at the anode, where, oh my gosh, that says reduction. Oh, no, it is. Because remember, they're always written as reductions. So you're taking the standard reduction potential at the anode, and you're subtracting it. Okay, so don't think too much into this. Okay, let's think back to that zinc and copper voltaic cell on page 9. We're going to take the cell potential of the cathode, which is where reduction occurs. So that was the copper one. That's this equation right here. And we need to find the cell potential of it. So the copper cell potential when it loses 2 electrons, not 1, and not when copper plus gains 1. It's this one right here. The cell potential for that is 0.34 volts. So the standard cell potential is the cell potential at the cathode. So 0.34 minus, okay, and now what's the other reaction is this one right here, but remember it's got to be written as a reduction. So it's basically these on the reactant side, this one on the product side. So it's zinc 2+ plus 2 electrons making zinc, which is this one right here. Okay, and then we go negative 0.76. So notice we subtracted the negative value. So it's the reduction potential at the cathode minus the standard reduction potential at the anode. And then you add those two together. What is the cell potential for that cell? Is 1.10 volts. And hey, what do you know? That's our voltmeter. Our voltmeter shows 1.10 volts. Okay? So if they give you two equations, if they give you two different equations, and I'll show you one here in just a second, and they say which one's the anode, which one's the cathode, you know that this cell potential value here must be positive. Okay, for a thermodynamically favorable reaction, the cell potential is a positive value. Okay, in the other type of cell, which we're going to learn about here in a few later videos, the cell potential is going to be negative. In an electrolytic cell, the cell potential is negative, and those are not thermodynamically favorable. Okay, but in all voltaic or galvanic cells, the cell potential must be positive. And if it's positive, then we know it is thermodynamically favorable. Okay, so let's say we have a cell set up with, and again, I'm just going to choose a couple here. Let's say with a silver. So we're going to do this one right here. And silver, and let's do nickel right here. Okay, and they're going to give you this equation right here, and they're going to give you this equation right here. And that's all they're going to give you. They're going to give you those two half reactions, and they're going to say, which one's the anode and which one's the cathode? And you're going to go, I don't know. Because they're both written as reductions. How am I supposed to know that? If they give you the cell potentials, just think, I can take 0.80 and subtract negative 0.25, or, and that again would be cathode minus anode, or I can take negative 0.25 and subtract 0.80. And again, then that would be the cathode, that would be the anode. Okay? Which one of those two gives you a positive answer? That's the only thing that matters. 0.80 minus negative 0.25 is really 0.80 plus 0.25, which is positive 1.05 volts. Okay? Where obviously this one is negative 1.05 volts. So that tells you that whichever one is 0.80 must be the cathode. And this one here, that's negative. That is isn't necessarily negative. It doesn't have to be negative. It could be like silver and copper. Okay, they don't have to be one number positive, one number negative. Okay, basically remember, whichever one has the greater standard reduction potential, whichever number's bigger, that's the one that's more easily reduced, and then therefore the other one is the one that's going to be oxidized. Okay, so what would that balanced equation look like? Okay, now that we know, okay, this one has to be the reduction process, so this one has to be oxidation. What does that overall equation look like? Well, now your knowledge of balancing redox reactions is going to come into play, because you've got Ag plus an electron making Ag, and then for this one we're going to flip it, because remember it's an oxidation process. So we're going to have Ni becoming Ni2 plus 2 electrons. And these are really, really easy. Remember all the stuff we had to do before. The only thing we have to do now to balance this is to make sure the electrons are correct. So we're just going to double this top equation here. So now we have 2 electrons lost, 2 electrons gained, and now we put them together. So the overall equation would be 2 Ag pluses plus Ni making Ni2 plus 2 silvers. Okay? And so once you know which one's the cathode, which one's the anode, you now know which one is reduction, which one is oxidation. You now know that the electrons are going to flow from the nickel side to the silver side. The electrons are going to move that way. You know that in the salt bridge, again, see how lots of things you can now do. You know that in the salt bridge that the NO3 minuses, or the anions, are going to flow to the oxidation side, which is this side. And the positive ions, the cations, K plus, let's say, are going to flow to this side. Again, you know everything about that voltaic cell now that you know which one's the reduction, which one is the oxidation. Okay, and again, there's lots of different ways that they do that. And in the homework problems, you're going to see there's lots of different ways that they try to get you to think which is the anode, which is the cathode. Okay, and that's where you got to use the clues that they give you to help you figure out, oh, this one's got to be the cathode, so the other one has to be the anode.